Welcome to the paper Maximum Silence to Noise, Sound Synthesis for Responsive Gestural Control. I'm Andrew R. Brown from Griffith University in Brisbane, Australia. In this paper I'm going to introduce a novel approach to ring modulation synthesis that I term Maximum Silence to Noise. I'll also introduce an associated instrument that's based on a pressure-sensitive multi-touch controller for controlling the MSN synthesis method. This is a video of a brief demonstration of a duet with John Ferguson and myself playing two of the instruments. Let me talk a little bit about some of the inspirations for developing this software and the instrument. One of the major inspirations was from the kind of DIY noise machines that are being made. I've got a picture here of the Bug brand board weevil from 2009. These kinds of devices are really interactive. They're quite noisy in the timbre that they create. This one uses a couple of square wave generators and ring modulates them together in order to produce some crazy sounds. They're also very responsive, and we wanted to kind of capture some of that in a software sense. Some other inspirations, particularly in relation to the interaction, are the kind of touch controllers. Sort of what's popular now as MPE controllers. The Harcum Continuum fingerboard has been doing this for quite a while and has been inspirational. And a similar software for that has been used on the Osmos Expressive E, which also has a focus on expressive gestural control. We're trying to bring these two things together in the instrument we're showing today. Let me talk a little bit about the synthesis algorithm, Maximum Silence to Noise. It's effectively modulation, ring modulation that is. It's a bit of a novel approach to it. There's two oscillators and they are ring modulated together, but those two oscillators morph between various waveforms. The display here, the image shows the waveforms. It starts with a DC offset silence, which where the maximum silence comes from in the name. Then that crossfades to a sine wave, then that morphs into a square wave and into a pulse wave, then into a couple of different noise types, a kind of crackly noise followed by a standard white noise. And we get a transition between these waveforms, and then there are two of these oscillators, these multiple waveform oscillators that can interact with each other to provide a very rich spectra. Here's an example of the maximum silence noise and its implementation in PD. First, we hear the just a single oscillator moving through those different waveforms. Next, we hear two of the waveforms interacting, being modulated together with each other. Both waveforms are scanning through the different waves in parallel, so they all start together with silence. Physically, the instrument that is playing back this synthesis method is a gestural controller, a touch controller. Well, actually the main one, which is the Rolly block we use, it's just a pressure-sensitive touch controller, multi-touch. It's used to trigger the sound. And we also use an iPad with another non-pressure sensitive touch controller for controlling parameters within the algorithm and within the software and for things like effects. The interaction gestures are up to two different fingers. So on the block you can either play with one finger, which will trigger one of the oscillators, or two, which will trigger both of them. The mapping is done so that from left to right is the crossfade across the oscillator from silence through to noise from left to right, and then from top to bottom, or bottom to top actually, is pitch from low to high. and pressure is applied to control volume. And this diagram shows that you can have a single finger gesture, either static or moving, and you can have a two finger gesture with one static and one moving, or two fingers moving, and they all create different types of sounds. The iPad is a fairly straightforward TouchOSC software interface for controlling the panning locations, the delay time and the delay level, the reverb time, the overall volume, and it's also used for triggering visual synthesis parameters. Often when we're performing, and you see this in some of the videos, we're triggering visuals as well as audio. So the data is sent from both of these controllers via MIDI to the computer, which is running the PD patch, and in the examples I'm showing you, the visuals are done using using Touch Designer. So the way in which we were testing these processes, first of all, there's a sort of synthesis testing, and that used a mixed methods approach where we just checked empirical results from oscilloscopes and spectrum plots as we moved through the various different morphing approaches that were taken between the oscillators and made sure that worked okay. It was also based on aesthetic judgments of just how it sounded and how smooth or otherwise those crossfades and or other processes, which we'll get into in a sec, were. The user interfacing testing was done through participant observation. We were designing to achieve a sort of an understanding that you only get through hands-on experience. These experiences were drawn from both John Ferguson and myself through solo and duet performances with the MSN instrument in Australia, in the UK and the US, so across the world between the years 2019 and 2025. In terms of the transitions between the waveforms, we tested various different sorts of transitions. Some of them work better than others for different parts of the spectra. The the sort of sine wave to pulse wave was handled by modifying parameter functions. In particular, we were just clipping and overdriving the sine wave to get to square. The square to pulse wave was done through frequency modulation to introduce that change in the pulse width. And then there was more straightforward crossfading used to get to the noise and the crackling waveforms. When we were working in our live performances, we were tweaking things, so there was an iterative design process in order to adjust and modify the different parameters and the way in which the pads responded. And that was done, as I said, over years. But we did find that we could get some very wide-ranging expression from the instrument. Here's a video of us performing recently, John Ferguson and I, on two of these instruments. So in conclusion, this paper has presented the maximum silence to noise algorithm and instrument. It's a novel approach to ring modulation synthesis. Its control is not so novel. There are many gestural controllers, but it's proved to be a very effective way of controlling this synthesis algorithm. We're reported on the outcomes of this development over extensive use in live performance. That live performances and hopefully the videos that you've seen briefly here show that it's quite expressive. The MSN software is available as a pure data patch from the GitHub site that's listed there on the slide. So thank you for your attention. Please get in touch if you want to hear more. Thank you.